on the basis of the n number of rainfall values corresponding to n number of stations. Okay, so give a heading: mean rainfall over a drainage basin. So write down, in a drainage basin, in a drainage basin, there are various sub-basins. There are various sub-basins each installed with a rain gauge. Each installed with a rain gauge. Full stop. The rain catch at one station, may be different from the other. Therefore, an average value of precipitation is found out. An average value of precipitation is found out. Okay, so we have various methods available with us. So are you able to see my screen? Okay,
Yes.
so first method here is called arithmetical mean method. Right. पहले हम इसी को डिस्कस करते हैं, arithmetical mean method. So as the name suggests, this method is very a simplistic method, right? So what you have to do, you just have to find out a simple average of all the rainfall values you have corresponding to n number of stations. All right, so write down, this is the simplest method. This is the simplest method where an arithmetical mean of the recorded rainfalls या आप इसको precipitation भी बोल सकते हैं, ठीक है? Even snow के case में this is okay. The arithmetical mean or all recorded precipitation at various stations is found out. At various stations is found out. How it is given? It is given by P bar equals to P1 plus P2 plus P3 plus up to Pn divided by n. All right. Simple. In summation form, you can write I equals to 1 to n Pi upon n divided by 1 upon n. Okay, where P1, P2, P3 will be the precipitation values at various stations. Right? Now, can anyone tell me when can we use this method? बहुत ही simplistic method है, पर क्या हर condition में use कर सकते हैं इसको? Can anyone tell me? Anyone? कुछ तो बोलो, विचार तो प्रकट करो अपने.
When the rainfall is uniform.
Yes, it's very simple answer, right? When the rainfall pattern is uniform along the catchment. अगर catchment में हर जगह almost एक जैसी बारिश हो रही हो, there is not much variability, and even the rain gauges are evenly distributed over the catchment, then we can easily apply this method, right? But otherwise, like in most of the conditions, this will not happen. Because topography will be different. Somewhere there will be mountain, valleys, forest area, plain ground, residential area, right? So then this method will produce a lot of errors. So right now, if the stations are uniformly distributed, if the stations means rain gauge stations, if the stations are uniformly distributed over the area, and the rainfall rate does not differ much, and the rainfall rate does not differ much from one station to another, this method gives satisfactory results. This method gives satisfactory results. But it may produce large errors. If there are many topographical differences, and rainfall rates are variable, or rainfall rates vary considerably. Okay, so then we have an improvement over this method. The second method is a improvement over this method. We call that method as Thiessen's polygon method. Thiessen's polygonal method. All right. So what Thiessen's polygon method says, suppose you are given with n number of stations. So first of all, join all those stations. So let's say, what can be a simple thing? Let's say there are 3 stations. Okay. So what I'll do, I'll first join these 3 stations by straight lines. So ultimately, I'll reach to some polygonal figure. So this is the most simplistic figure, right? I have a triangle. Now, say I have some 4 number of stations in a catchment, then I'll be joining all those stations through lines, and I have reached to another figure. What is that figure? That figure is some kind of a quadrilateral. Okay, that now it is not necessary that it will be always be a square or a rectangle. It could be any kind of a non-uniform figure. Okay, it could be anything. So then what the method suggests, see, there is no hard and fast rule how you assign an area to all the individual stations, right? What we are doing here is that we are assigning a certain area to each station. Okay, for example, let's say if this is a square pattern that is formed, so what I'll do, it is simple for me that I might divide it into 4 equal parts, and let's say for this particular station, I'll give this as an area, right? Now for this particular station, I'll give this as an area. Now for this particular station, I'll give this as an area. And similarly, I can give this station the area like this. Okay, so यहाँ पे तो क्या है? The things are perfectly symmetrical. So very easily you can divide the area into 4 equal parts and give an equal area to each of the stations, right? So this station will, if the entire area is say A, then each of these areas will be A by 4, right? And then what we do, we take a weighted average to find out the mean precipitation. How? In that case, the P bar will be equal to P1A1 plus P2A2 plus P3A3 plus up to PNAN if there are a number of areas divided by the entire area A. Okay, this is how we proceed to the method. I can also write it like Pi AI I equals to 1 to n divided by A. So this is the weighted average. ठीक है? अब weighted average क्यों ले रहे हैं? Why we are taking the weighted average? Because it has got an advantage that suppose if by chance this station covers a larger area. Okay, suppose this is P2 rainfall value, this is station number 2, and this covers a larger area. Then here the weightage of P2 into A2 will also be large. You getting the point? So इस मेथड का यही एडवांटेज है कि जिस स्टेशन के पास जितना ज्यादा एरिया होगा, the same amount of weightage will also go to that particular precipitation value, and it will affect your P bar in the same way. All right. So now, अब यहाँ तक किसी कोई दिक्कत है क्या? Anyone has got any doubt?
No, sir.
All right. So now the figure can be complex, but it is on you how you divide the area. But say if you are able to make a quadrilateral figure something like this, then it is recommended that you join the diagonals first of the stations. Okay, ठीक है? ऐसा करने से क्या होगा, अगर आप डायगोनल्स को ज्वाइन कर देंगे तो ये ट्राइंगल्स में डिवाइड हो जाएगा ये एरिया, ठीक है? And once it is divided into triangles, that you can assign a particular area to a particular station, right? अगर उसमें भी ऑप्शन लेना हो, अगर एक ही डायगोनल ज्वाइन करना हो, तो then it is recommended that you join a shorter diagonal. But these are all recommendations. It's on you how you divide the figure into. Okay. Now say if I have this kind of a figure, or my stations are located like this. There is a station here also. I have joined all these stations. Now obviously I have to join this station also through various stations. Right? Now there is a middle station also, and there are 4 stations at the side. Now what we'll do? अभी हमें इनको भी एक एरिया असाइन करना है जो कॉर्नर स्टेशन है, ठीक है, और इस सेंटर वाले को भी एक एरिया असाइन करना है. So then what we do, when a triangle is formed, it is better to divide the triangle into parts. ठीक है, समझ में आ रही चीज? तो how can we divide the triangle? अगर मान लो ये एक triangle है and it is having 3 stations, then how can I assign the area? Is there any method that I can divide this triangle into most probably equal parts? Anyone knows? So I tell you, you might have learned in your geometry that the best method to divide the triangle into equal parts is to draw the perpendicular bisectors. All right, so just draw the perpendicular bisectors like this to this side. Okay, then probably you can draw from here also like this, and you can draw onto the third side from here also like this. ठीक है, इस तरीके से अब आप चाहें तो सारा एरिया एक एक करके डिवाइड कर सकते हैं. Like you can assign this area to this particular station. ठीक है, and maybe you can assign this area to this particular station, and you can assign the remaining area to this particular station. All right, so all the stations will be given 1/3 of this triangle area. ठीक है, it is just a recommendation. ठीक है, इस तरीके से आप यहां भी कर सकते हैं. अगर मैं इसको भी डिवाइड करने की कोशिश करूं 3 equal parts में, let's draw the perpendicular bisectors from onto the 3 sides like this. So maybe I can assign the 1/3 area of this particular triangle. You can see my cursor, this particular triangle, the 1/3 area will go to this particular station. ठीक है, मैं भी इस ट्राइंगल की बात कर रहा हूं. लेट्स कॉल दिस ट्राइंगल ABC. All right, but this is also shared within this area. So if you don't know the area of this triangle, you can further divide this triangle also into 3 equal parts and assign this area to this particular station B. All right, so what happened? This station B got 2 kinds of areas, one from this ABC and one from this, say, D, this triangle ABD. ठीक है, 1/3 of this triangle ABD and 1/3 of this triangle ABC. So 2 kinds of areas it will get, and the summation of this area and this area will be the area for station B. Okay, similarly there will be a similar area for station D. Station D के लिए area कैसे आएगा? Now this area 1/3 of this triangle, and if you are again drawing perpendicular bisectors here, then this area will also go to station D. So station D will get this area and will also get this area. Okay, similarly you can have areas for these stations. Maybe you can call this as E, station E, and also for station C. In the similar way you can calculate the areas. All right, now what about the center station? अब सेंटर स्टेशन को भी आपको एरिया देना है. ठीक है, तो in this case you can give this area to station A, maybe some area from this triangle, maybe 1/3 of this triangle, so this area, or in an alternate way, these are all recommendations, so कोई hard and fast rule नहीं है, ठीक है? अब सपोज कीजिए ये कुछ ऐसे स्टेशन है आपके पास, और यहाँ सेंटर पे भी एक स्टेशन है, तो यू माइट सेपरेट द एरिया फॉर दिस सेंटर स्टेशन ऑल्सो। अगर मैं चाहूं तो इनके सेंटर लाइंस ज्वाइन कर दूं, ठीक है? तो मेरे पास एक सेंटर एरिया निकल के आएगा, and this center area can be assigned to this middle station, right? And the corner areas might go to particular these stations, ठीक है? अब ये जो एरिया है ये इसको ट्रांसफर हो जाएगा, ये एरिया इसको ट्रांसफर हो जाएगा, ये एरिया will go to this and this area will go to this, and the center area we have already secluded. So it all depends on the geometry of the figure, how easy you find to divide the figure into. All right, so that's all your judgment. Fine, so just write down something about this. किसी को कोई दिक्कत है क्या यहाँ तक? Anyone else got any doubt? All right, so write down in this method, the adjacent stations, in this method, the adjacent stations are joined by a straight line, thus dividing the entire area an entire area into series of polygons right in bracket, generally quadrilaterals and triangles, because these are very simplistic figures. Further right, after that, perpendicular bisectors are drawn on each of these lines so that a particular polygon is assigned to a particular rain gauge station, and the average is found out by this formula. You can write down this formula, P bar formula, and the average is found out by P bar equals to P1A1 plus P2A2 up to Pn divided by A, the entire area. Okay, written now. नीचे एक नोट लिखिए, to divide the area into triangles, Most frequently, most frequently, shorter of the two diagonals, shorter of the two diagonals is joined, is joined. All right. So this was method number 2. Now we come to next method, method number 3, which we call the Isohyetal method. Okay. Anyone knows what is isohyet? Anyone has any idea what are isohyets? Acha, I have told you that the rain gauges are also called hyetometers. Do you remember? Right?
Yes, sir.
And ISO represents the points having some same readings. ठीक है? जैसे ISO bar होता है. What are ISO bars? Bar refers for pressure. ISO refers for same. So these are the points which represents the same atmospheric pressure or same pressure. Right? Now you have contours. So contours represent the points having same elevation. Okay? Similarly, we have isohyets. So these represent the points having same rainfall. ठीक है? तो इसमें क्या करते हैं isohyetal method में कि say I am having this much of a catchment area. So I'll first divide my catchment area on the basis of rainfall contours or isohyets. ठीक है? तो पहले मुझे क्या करना पड़ेगा इसमें isohyets draw करने पड़ेंगे. So maybe let's say I have isohyet here outside the catchment. Maybe say that is a 4 centimeter isohyet. Then maybe I can have an isohyet here. Maybe that is something around a 6 centimeter or 7 centimeter isohyet. And I'm also having some rain gauge stations here. So maybe I could have a rain gauge station here. I could have a rain gauge station here. So जो contours draw होते हैं, जो isohyet draw होते हैं, they are drawn taken an idea from the rainfall values at these stations. Right? For say, suppose here I am having a rainfall of 7.1 centimeter on an average. Now here I am having a rainfall value of say 7.9. Okay? There might be other rainfall stations also which are giving me some other values like 7.5 or something. ठीक है जो रेनफॉल होती है वो इसी तरीके से डिस्ट्रीब्यूट होती है कैचमेंट में इट हैज अ डेफिनेट पैटर्न ऑफ डिस्ट्रीब्यूशन right so wherever the storm goes according to that storm the distance from the center decides how much rainfall is going to happen at a particular station right so on that basis 7.1 is somewhat nearer so I have drawn a contour here marking it as 7 ठीक है you might draw a contour here somewhere here marking it as 6 okay similarly we can have contours here which are say an 8 centimeter contour now we can have contour here which might be a 10 centimeter contour depending upon the rainfall distribution all right sometimes we have circular contours also like this because there might be an area which is very having a very lesser area and it is having some particular rainfall value you might can you please mute someone has unmuted Excuse me, can you please mute yourself? Ujjwal Tyagi. Mr. Ujjwal, can you please mute yourself? Anyways, so that might be a particular area which is getting a extraordinary rainfall, maybe 12 centimeter or something, right? So on that basis, we calculate the area which is contained by each contour, right? And accordingly, we apply a formula for the weighted average. The formula वही रहता है यहाँ पे भी. The average precipitation is calculated by P1A1 plus P2A2 plus up to PNAN divided by the total area. Okay, but these A1, A2 are the areas which are contained by these contours. Okay, for example, let's say there is a contour which is 8 centimeter and here is a contour that is 10 centimeter. So if there are no other contours in between, so I'll mark this area of the catchment which is contained between the contours, say AI, this is area AI, and the average of these two contours will be taken as the precipitation value for this area. Okay, that means the average of 8 and 10 here will be 9 centimeter. So this will be the PI for this AI. ठीक है, अगर सपोज एरिया A2 है तो मैं इसे P2 असाइन करूंगा 9 सेंटीमीटर को इस फॉर्मूले में. सिमिलरली यहाँ पे भी कुछ एरिया होगा इन दो कंटूर्स के बीच में. ठीक है, अगर सपोज 7 सेंटीमीटर कंटूर है, ये 8 सेंटीमीटर कंटूर है, द एवरेज ऑफ दीस टू कंटूर्स विल बी 7.5 सेंटीमीटर. So that will be PI for this area and the area will be AI. Okay. So similarly, we find out the areas for all these stations or for all these contours, and we assign a particular value of precipitation on the basis of the average of the contours. Right? Is that clear? So now the catch is how these areas are calculated. तो यहाँ पे जो सबसे टिपिकल पहला काम है that is to draw the contours or the isoheights. Okay. Otherwise, this method is very accurate. If you are properly able to draw the contour, which requires some experience also, then you can properly estimate the mean average rainfall of the area very easily, right? So maybe you can draw a map of an area, and obviously you can measure that area with the help of the planimeter. ठीक है, ग्राफ पेपर में इस एरिया को प्लॉट कीजिए, उसको प्लानीमीटर के ऊपर रखिए और प्लानीमीटर से टू द स्केल उस एरिया को मेजर कीजिए और कन्वर्ट कर लीजिए अकॉर्डिंग टू योर स्केल. Alright. But what happens, since I have told you that the planimeters always measure from one end to another end. So what it will do? It will measure this area up to this contour. But if you want to measure area up to this contour, it will measure from here to here. So as I told you, if you have to find out this area, then you need to subtract this previous reading from the next reading. तो कभी कभी आपको एग्जाम में ऐसा भी मिल सकता है कि accumulative area is given. ठीक है, like for 7 centimeter contour you are given with a 2500 kilometer square area. For next 8 centimeter contour you were given with a 4500 kilometer square area. For next 9 centimeter contour you will be given with maybe 6500 kilometer square area. Then you must know that the area that is contained between this contour 7 centimeter and 8 centimeter is a difference of these. ठीक है, अगर ऐसी रीडिंग्स आपको मिल रही हैं ऑलवेज इंक्रीजिंग ऑर्डर में, So then you should understand by default that these are cumulative values. Okay? And you need to find out the difference between two values to get the area between any two contours. So the area between these two contours will be around 2000 kilometers square. Again, the difference between these two is around 2000 kilometers square. Maybe for next 10 centimeter contour, you will be given a reading of say 8000 kilometers square. Okay, so for between 9 to 10 contour, you will have to take an average, the difference between the readings of these two areas, that is 1500 kilometers square. So in this way, you can have the areas AI, A1, A2, A3, and you can have an average of these contour readings as P1, P2, P3. So your P1 will be 7.5 centimeter, your P2 will be 8.5 centimeter, and your P3 will be 9.5 centimeter. और फिर आप इस फॉर्मूले में इसको रख सकते हैं. You got it? How it works? So I have told you this is a possibility, but not always you will get reading in this fashion. ये भी पॉसिबल है कि जिसने आपको एवरेज निकालने दिया है उसने पहले ही ये डिफरेंस ही आपको लिया हो. तो डिफरेंस अगर वो लेगा तो रीडिंग्स अनइवन होंगी. They will not be always in increasing or decreasing order, right? Like this. Might be constant, might decrease, might increase, like that. तो इस तरीके से है तो फिर आपको डिफरेंस करने की जरूरत नहीं है. Then you must know कि पहले से ही डिफरेंस करके दिया गया है. And if it is always in a increasing order, then it means that some cumulative reading is given and you need to find out the difference. All right. So my time is up for today. Anyone has any doubt up to here? So today there are 43 students. So उसमें शायद एक तो मैं होऊंगा, पर more than even the class strength.